afternoon. At the outset, I would like to thank Peninsula and Peninsula Foundation and Air Marshal Matheswaran in particular. When I was asked to speak on cooperation in the area of, how to promote the blue economy, especially from the point of view of technology cooperation. So, technology in this case is a very vast technology, right from, I have worked in the area of aerospace, and I find that 90% of that applies to the blue water economy, blue economy. So, I'll take you through, of course, my previous speaker has spoken quite a bit about cooperation in this area, and let's basically we are looking at cooperation with others. In terms of technology, there are two things: either you use technology or you transfer technology. So this could mean both. That is, somebody allows you to use his technology for your work, or you are going to get that technology to improve your purpose. So in this, as brought out earlier, the Government of India, as through its ministries, I am not saying one ministry, has focused on quite a lot of work in the Indian scenario. So we are talking about deep ocean mission, oceanography from space, and also launching of the data buoys. But actually, it means more as we go along. In order to understand, see, when you want to get technology from somewhere, you need to be at a particular level in technology yourself. You cannot go and give technology to a nation which is very poor, which doesn't have any background. So I wanted to highlight where we are, to quickly highlight where we are with reference to some technologies. See, for example, we have been hearing about fisheries for a long time now, since morning, and the Indian INCOIs and SO, they have done this work of satellite-based advisories depending upon availability of food, because the food for the fish is available and then the fish will be there. And these things have been, advisories have been provided since 2000 in our country. So we are quite well advanced in many of these things. And so you can see the catch increases 2 to 4 times and additional income comes. Now this is based on certain level of technology. We have, it's our own satellites, or sometimes we borrow data from other satellites. Similarly, location of placer materials, a lot of indigenous mining techniques have been developed through all these organizations. We are there now, but where to go, we'll find out. And also technologies in terms of development of, all these deep sea technologies, the Admiral mentioned underwater. We are talking about commercial utilization and low cost-effective vehicles for doing so. These have been progressed, and the most advanced, called Matsya, is under development. It will be launched very soon. A lot of money has been sent on it, 300 crores plus. And similarly, as we are surrounded by the sea in the peninsula, we need to have data about the weather, climate, and as we discussed, the yield. Basically, what's happening here is that a very complex system like the oceans and the winds, etc., cannot be understood in a simple manner. So you need to build a model. Computer simulation, we were taught a long time back, is whenever you cannot solve it yourself, It's beyond comprehension. You put all the factors together and write programs so that the computer can solve it. So the importance is to build a model. Importance is to build a model of the ocean, the entire climate. And this is possible only when you cooperate. We'll see how we do this. Some advancements in, you remember the cyclone warning, especially for the Hud in Odisha, where we were watching it like a cricket match. That they predicted that it will cross the coast at a particular time, and it was, it was precise. It was astonishing technology, because in the same area, we have lost 50,000 or 1 lakh people earlier. Here, there was hardly a couple of, tens of people. From tens of thousands to tens of people have damages. This again is advance in technology and science, and we should be proud that it was done by our guys, and they could predict it better than the international bodies. So in order to do all this, similarly we have also established a tsunami warning system, and it was established by us, our own, of course some of the sensors etc. were bought out, but the whole network designed and planned was done by us, and we are quite safe now with respect to tsunami. And this still needs improvement, because you can always improve things with science and technology. Harnessing technology. Technological instruments, when you want to do support blue economy, you need acoustics, optics, radars, operating underwater vehicles, satellite oceanography, sonar and animal telemetry, including instrumenting whales or other fish, etc., and locating them, look at migration, to study migration, etc. So India launched a deep ocean mission in 21, and it's going on very well. But we will we'll see how it. We have worked at NIAS on space situation awareness, just like what Admiral talked about, maritime domain awareness. These two are related very closely, and it is possible only with contributions from other people, however strong you are. For example, you take the US. The US could see the oceans from satellites. The satellites are sometimes 26,000 kilometers away, or sometimes more, or sometimes as close as 500 kilometers, low Earth orbits. But they still cannot. The sensors on those satellites have certain sensitivities, certain measurement accuracies. Like you want to measure the wind, surface winds on the ocean, the accuracy will be limited because of the distance. You have to carry precise instruments up there, and it is expensive, and such equipment may not exist also. But suppose you locate them on buoys, you have local data collection. It will help the model. It will improve the measurement and improve the computer model, and hence you will get much better results. So it is very clear that India or the rest of the countries will have to work with the rest of the countries in order to gain maximum out of the computer prediction models and use it for the blue economy. A plan to understand the requirements of our maritime neighbors. This is the way we go about it, and offer focused assistance for the capacity development through supply of hardware, training, joint operations, data gathering, sharing for the better marine domain awareness and disaster relief should evolve. So this is not only from us to lesser developed countries, it's also required from the better developed countries to us, because this ocean is affecting. It's only one ocean finally. All the 7 seas put together, it's all one ocean, and hence It's going to affect all of us together. And there are many, the the developed nations have realized it long time back. And you can imagine a international Indian Ocean expedition was done from 2015, it's going up to 2025, in order to collect data again. It's collection of data. So if your country doesn't have the ability to launch satellites, there are quite a lot of data available on the satellite data collected by the Western satellites. Over and above that, you help that model by making your own measurements at local level, and hence you cooperate with each other. So as I said, it's very difficult for a single country to generate knowledge on the Earth system science. It not only applies to just oceans, but other Earth objects also, including, for example, earthquake prediction and all that. So international partnership to improve understanding of the Earth system process is very essential. Converted knowledge into products and services for weather, climate, ocean, for the country and neighboring region, like BIMSTEC, etc. So an effective collaboration to build observational systems, data standards, and exchange prediction systems, networking of required. So the key word here is networking. And you network just not through connecting one place to another, but what you send in them, what data you want to send in them, and how to interpret the data. So standards, already there are, as we can see, like for example, Group on Earth Observations is a Swiss-based, it's an international effort. They have a global Earth observation system of systems, integrate observing systems and share data by connecting existing infrastructures. There are more than 400 million open data resources in GEOS for more than 150 national and regional providers, such as NASA and ESA. So, thanks to the growth of technology in the West, we have all the data available. Now, we'll have to integrate ourselves into their network. I'm talking about all the countries, not just India, in order to bear fruit. This again, more data on Blue Planet. The Admiral touched upon maritime domain awareness. I'm just bringing it here to just show that what level of technologies are involved, right from so many satellites for the purpose of search and rescue, and for example, GPS and the automatic identification system, which is essential for GPS is essential for AIS. But then GPS, it can be, as we know, in the Ukraine war, we have seen GPS can be jammed. So there is a big problem with that. How to overcome these things? As we mentioned, cyber security is a very important thing. See, for example, the AIS fellow can simply spoof the rest of the crowd. He can confuse the entire monitoring system by transmitting wrong things. And he himself can be fooled by another fellow, neighboring fellow. So these systems which are supposed to be used in a simple manner can get complicated when we talk about terrorists, and also nation states themselves are doing this. So it's very essential to sort of cooperate in this area, and the MDA by JAXA, they are also very powerful. Japanese have done excellent work in this area. Now the latest, that Quad, data from multiple sources such as coastal radars, ships, aircraft and satellites are pooled and analyzed in a single platform in close to real time. So he mentioned about the Information User Center, that's in, it's collecting, using all this data. These systems rely on automatic identification system, which is good for keeping track of white shipping, illegal fishers, drug smugglers, etc., they just turn off the AIS system. You don't need to jam them. They just, and many of the guys are so poor, they don't have a AIS system. So how do you track them? So through Quad, the Indo-Pacific Partnership for Maritime Domain Awareness, we are getting additional enhanced version of the Sea Vision platform, which is meant for MDA, is being made available to the member countries. India is one of them. Sea Vision is enhanced by including electro-optics imagery, synthetic aperture radar data to build a 3D picture of targeted vessels, helping to identify a drug smuggling though or mothership. Data from the visible infrared region, radio, etc., etc. So this is it's a great help in terms of being able to identify the maritime domain awareness, because once we don't have this awareness, it will affect everything, shipping, fishing, and the blue economy will go for a toss. Now, actually, when they turn off their beacons, that is AIS transmissions, what do you do? So, what we use electronic warfare technology during combat is being used here by this systems satellites called Hawkeye 360s. So 3 of these satellites separated by 300 kilometers, they go around and they pick up signals from the vessels. Even if you use your mobile phone or any emissions, they can pick up across a big vast frequency range and locate them, and helps to complete the maritime domain awareness. So these are the benefits that we get when we go to the cooperation mode. And space, any nation, including US, should cooperate with others in order to improve the domain awareness. Air Marshal also requested me to talk about pollution. Again, we are talking about plastic elimination, and national marine litter policy became an imperative. But the very important thing that we should see is, for example, the plastics are not produced by the ocean, they are produced by us. And the arteries, the main shipping line or the route, supply chain for that are the rivers. Okay.
Professor Soundar, Rajan?
Yes.
It's just one.
So we are Mekong, and our own mother Ganges is a major contributor to this. So we need to do quite a lot of cleaning ourselves and stop it from entering the ocean, because you will see it is extremely difficult to pick up this. Cleaning the ocean is not easy. You won't believe that. When I saw this picture, I couldn't believe how a light plastic bag can go to the bottom of the sea floor at 36,000 feet. I wouldn't have believed it if this photograph was not by NOAA. And the other method of collecting, pulling all them at the surface and collecting them will not work, basically because they are also killing, spending additional fuel to pollute the earth, and also collecting a lot of life from the surface. So this is also debatable. So the only way is to stop being producing and stop at the river mouth. One thing that has not been talked about is electronic pollution. We are talking about plastic, but you can't believe the number of versions of iPhone that are coming out. And the moment you get a new one, new one is announced, we throw the other one, literally. And all that chemicals, you see, electronics is a host of toxic material inside of them. Okay, LCD monitors too. It's unbelievable. So there should be a method of controlling this. And the one good news that we are talking about, additive or subtractive. Against additive, we can talk about subtractive manufacturing, because when you do additive manufacture, you build a thing, you build it up. So there is no wastage of material. The traditional method, what we do is we take a piece and then remove material from that. So anything that you remove and throw is waste. So this is one great advantage, and especially if you going with more and more metal printing, then it will reduce the, and of course there are many advantages of additive manufacturing to produce maritime systems themselves, but I am not talking about that. I will end my talk here. Thank you.